Yeah, homework question 6.23. They tell us this lamp generates 9.8 times 10 to the 20 photons with a wavelength of 434 nanometers. Right, they're looking for how much energy is released in kilojoules. So first, we can find energy, knowing that we're going to find energy per one photon, and we need to do that with a wavelength that's in meters. So got 434 nanometers. I know in 1 meter, I've got 1 times 10 to the 9 nanometers. So my wavelength is 4.34 times 10 to the minus 7 meters. Now I can find the energy of that light, right? Energy equals Planck's constant, 6.626 times 10 to the minus 34 joules times seconds. My speed of light, right? 3 times 10 to the 8 meters per second over my wavelength, 4.34 times 10 to the minus 7 meters, right? For this second step, we were just using energy equals Planck's constant, the speed of light, over my wavelength. We find the energy, that's the energy for one photon. So 6.626 times 10 to the minus 34 times 3 times 10 to the 8. And we divide that by my wavelength, 4.34 times 10 to the minus 7. I get an energy of about 4.58 times 10 to the minus 19 joules per photon, right? This is the energy for one photon. We release 9.8 times 10 to the 20 photons, right, with this lamp. So, all right, I've got 4.58 times 10 to the minus 19 joules per photon. I release 9.8 times 10 to the 20 photons. It's going to give me, right, photons cancel out. It's going to give me energy in joules. So times 9.8 times 10 to the 20th. And I get about 448.85 joules. We're looking for the energy in kilojoules, so I've got one more step to go. 448.85 joules. We know in every 1 kilojoule, we have 1,000 joules. So we divide by 1,000 to get approximately 0.45, right, to 2 significant figures. I would go to 2 significant figures based on the 9.8, so 0.45 kilojoules of energy for question 23.